there, this is Super White Trash Guy Fred who lives in the RV, and today I'm going to be talking about a real world situation regarding solar energy. Now here we got 3 solar panels. They're pretty much all identical except this middle one, but yet my testing they're pretty much still identical. When the sun is out, but it's not out so much today, it produces about 18 to 20 volts. Each one produces about 0.8 amps. So combined total, it's almost producing close to 3 amps of charging power. Now, even though it produces about 20 volts, really doesn't matter. It's still 12 volts to the battery. Now, as you can see here, looking at the sun over there, the sun's not out so much, but that's okay. Because these things were charging all day, yesterday, today, and the past days. And we're going to go inside, and I'm going to show you a little bit more of this very simplistic solar power system. Now down here you can see I got 3 12-volt batteries, and I'll get into a little bit about the wiring a little bit later. But first, those solar panels, all those wires end up at this connection area here, as you can see. Now I know it's a little bit messed up, but let me simplify it for you. There's a negative NE and a positive, okay? And those all get connected there, negative, positive, okay? Then from there, what you want to do is you wire it to what's called a charger controller. Now what this does, it allows the battery to still get the voltage and the amperage without going over 14 volts. Once it hits the maximum, there'll be a green light that turns on. Right now you see a little orange light, which just means that we're getting power from the solar panels. Now from there, those lead out to this big mama battery here. Now I don't think it really matters what size battery comes first, but what we do is we run the wires in so-called parallel. Now, you're probably used to like your Walkman or your boombox, and you put the batteries to plus, minus, plus, minus, plus, minus. So normally a 1.5 volt battery you can make into 6 volts by running it plus, minus, plus, minus. Now, we got 12 volt batteries here. We got 3 of them. That does not mean we're creating 36 volts of power. We're actually still creating, as I can show you here, we got a whopping 12.65 volts. Now that's all coming from these batteries here, because I run it parallel. Positive, positive, positive. Negative, negative, negative. That's pretty simplistic. Now as you can see here, I got this really bright LED light. And this bright LED light is being ran off by my freeway electrical system I have up here. I call it a freeway because, I don't know, it kind of looks like a freeway. But what I do is, from the batteries, gets connected here. Now what I do here, just for simplistic reasons, I make a knot. Knot always to me means positive. And so basically I can attach anything on my freeway system here to power up everything. So basically right here we got a positive, and that goes all the way down to my really bright LED light. Got it? Good. Now you're probably saying to yourself, well, what good is an LED light with all these batteries? Pretty much nothing. It's just my utility light. The heart of the system here is my inverter system. As you can see here, that's my inverter. Basically it takes the 12 volts and converts it into 110 AC power. And that goes up here. And the test today that I'll be showing you is we're going to be running a mini Mac with about 110 volt power supply, which is totally different than a power supply off this computer system, which is 650 watts. Now, I've tried this before on the 650. I'll get back to you on that. It just draws way too much power. So we're going to do a test here on my mini Mac power supply. I also got another 12 volt power supply here. As you can see, let me get my light there. That's going to be running my external drive, And then I got another little white wire there, and that will be running my light bulb. So from here, let me show you what the voltage is. You see that? Running at 12.64. Now, let me show you something interesting. If we plug in a different voltmeter, like this guy here, this guy's saying 12.75. Well, I know you don't think it's 75, but if I push this a little bit, look at that, 12.76 compared to 12.64. So if I take off my LED light, now look at the voltage drop or go up. Sorry about that. So when I plug it in, the voltage drops. You got it? Good. Now, we're going to do something incredible here. We're going to turn on the main inverter. Here we go, and that's going to power the Mini-Mac. An external drive and a light bulb. Here we go. Bam. Green light's on. We got a light bulb up there. See that light bulb? It's shining nicely, and it's going to get brighter too. And now let's turn on that Mini-Mac over here. Here's that Mini-Mac. Got that cooking. Now I know I said I was turning on my Mini-Mac, and that's true, but I ain't running no Mac OS. I'm running Windows XP on that Mini-Mac. You know why? Because I'm a super white trash guy, and that's how I like it. Got it? Good. Now check out this. We're running 12.43. Give or take 44. 43, 44. In any case, before this thing was running at about 12.67, if you recall. So we only reduced the voltage just a tab, I tell you. Now, if we were just running one battery, but we're running a whopping 3 batteries here, and that's why the voltage hasn't dropped so much, because the voltage is being retained by 3 batteries. Now, what this is called when you put more than one battery is called a battery bank. The more batteries you can deposit in your bank, the better off you are. You got it? Good. Remember that. Battery bank. So there you have it. This is super white trash guy Fred, who's making videos out of his trailer, and we're talking about solar energy. As you can see up there, solar is the name of the game.